setup, that's what I would do. Does it make sense to you?
Yeah.
Now, what others would do, which is still correct, is they would take, instead of going from 2 pi over 3 to pi, they would go from pi to 4 pi over 3. Still correct. So instead of them, so let me take this, if I take that out, what they're doing is they're subtracting that, right? They're subtracting that part of it. Whereas I was saying, you know what, it doesn't matter based on symmetry, let's subtract the bottom half of the inner loop. But if you want to subtract the upper half of the inner loop, you can do that by using the limits of integration from pi to 4 pi over 3. Question?
Could you go for the first one, like 0 to 2 pi, and then multiply that by 2, and then just subtract another integral from 2 pi over 3 to 4 pi over 3?
Okay, so now let's talk about, so now that we've done this, because that's kind of a similar question to what Andre said, so I said let's wait until after we've talked about this. So now that we've done this, let's talk about what would happen if we did what Priscilla or Andre are asking to do. So let's think about this, right? If you have the integral, so I guess here's my question. What does this give me in terms of the area? What does it give me? Yeah?
The area of the entire limit of the
No? This is a very good question. So I really want you to think about this in terms of sweeping through. Yes?
What would happen like where the blue and like the red meet? Would that like?
Well, so we'll talk about that, but all I'm asking is, what does that give us? The 1/2 times the integral from 0 to 2 pi of r squared d theta.
Give you the area of like 2 times that whole light blue area plus the inner loop as well, because it sweeps through that whole top half and then again through the inner loop.
So yes, but I don't feel like people really understood that. So really what it is this whole thing plus an extra one of those. Too many inner loops. So let me keep going from what I have already done. So let's remind you. The blue highlighter is from 0 to 2 pi over 3. Do you see how that already includes half of the inner loop? Okay, plus from 2 pi over 3 to pi, that's another half of the inner loop, right? Do you see that? Plus, if I were to go from pi to 4 pi over 3, that's another half of the inner loop. Do you see that? Are you seeing that? Because from pi to 4 pi over 3, I'm now having another half of the inner loop. And then if I go from 4 pi over 3 to 2 pi, then it's going to include this stuff, which includes another half of the inner loop. So here's my point in your question and your question. I feel like the reason why you asked your question was you wanted to simplify everything. To, hey, can I just do the whole thing minus just that? But in doing the whole thing, you're including what we're trying to find and 2 whole areas of the inner loop. Because it's half there, half there, half there, and half there of the inner loop, which is 2 full inner loops. Do you see that? Yes? So in order to do what you guys were suggesting, it would have to be what I have up here in black minus, so let me erase that. Minus 2 of the inner loops. Well, each inner loop is 1/2 times the integral from 2 pi over 3 to 4 pi over 3 of r squared d theta. How many of you were able to follow what I just did? All right, so in trying to simplify it, you gotta think about exactly what's happening, because it's possible that you're adding or not taking away enough of what you are really looking for. That's why when I'm doing a problem like this, I break it up into this whole sweeping out motion using my highlighters so that I can really see what that area consists of. So for the integral from 1/2 times the integral from 0 to 2 pi over 3, I already have half of the inner loop in there included. So then I got to take out only half of the inner loop. And then take that and double it. So that's why I opted for this first in black down here. That made more sense to me. Whereas this is a little bit trickier. There, go for it.
Just like the second time that you like loop, I don't know how to explain it. The second time that you loop into
Give me theta values.
origin, that's what I'm trying to ask. What is the theta value of the second time that you like loop around?
Check it out, check it out, check it out. Theta is equal to 0. Positive in the first quadrant. Theta is pi halves. Theta is equal to pi halves. Theta is positive and r is positive until theta gets to 2/3. Then, even though my theta value is, 2 pi over 3, my r value is 0. And in the second quadrant, as theta moves on, all of those r values are negative, so it's bringing it back into the diagonal quadrant, which is the 4th quadrant. So even though your theta value is in the second quadrant, your r value is negative, so it's bringing you back into this 4th quadrant until theta is equal to pi right there. Again, at theta equals pi, I'm back at -1, which we saw. Does that make sense?
Yeah.
And then, as theta is in the 3rd quadrant, your r values are still negative until you get to 2 pi over 3. Then your r value is 0 again. And then this little portion of it is when your theta values are from 2 pi over 3 to 3 pi halves. You're going zzz, and your r values are positive there. And then all in the 4th quadrant, your r values are positive, and it's going out until it hits this value again when theta is equal to 2 pi. Did that make sense?
Yeah.
So, you're starting to see a little bit of the difficulties that we